Hi, welcome to another video in my series on solving differential equations. Now, with this one, at the end, it's the way we manipulate the constants that can vary. So it's a good example to try, okay? Now if you'd like to try it, just pause the video then and come back when ready. You can fast forward and check your answer at the end. Okay, welcome back if you did have a go. So how would we go about solving something like this? Well, it's a differential equations where we separate the variables. That is, put the x's on one side and the y's on the other side of the equals. And to do this, I would want to divide both sides by y and by x minus 4. And so therefore what I'm going to have is 1 over y dy by dx equals 3 over x minus 4. Okay? Now I haven't quite got all the y's on one side and all the x's on the other side of the equals. I need to get rid of this dx. And oh, by the way, I could have divided by both sides by the 3 as well. That would have given me 1 over 3y. Nothing wrong in that, but quite often it's a good idea just to leave constants, if possible, on this top level here. Okay, so we've got to get rid of this dx here. And to do that, we place it up here. This is almost as if we multiply both sides by dx. But at the same time, we must integrate both sides. So therefore, we need to put the integral of 1 over y dy equals the integral of 3 over x minus 4. And that's integrated with respect to x. Now, you might want to go from there straight to this line if you can, that's fine. Okay, you don't have to go through this stage, but I'm just breaking it down in slow stages for you to see. Now we need to integrate both of these sides. So the integral of 1 over y with respect to y, well, that is the natural log of y, and don't forget we need to put that in a mod sign there. We'll leave out the constant on this side, we'll just group it with the constant on this side. So if we integrate 3 over x minus 4, we can see that this is going to be 3 times the integral of 1 over x minus 4, which is the natural log of the mod of x minus 4. I'm assuming that you're familiar with these integrals, okay? So on that basis, we'd have a constant from this side, a constant from that side. Once we bring one constant over to the other side, we group them together and just have the one constant. Let's call it c. Now, we need to tidy this up. Suppose we're asked to make y the subject. Well, in this integral, we've got 2 log terms. And we need to bring them together, or that's certainly one method, and I'll show you another method towards the end. So we'll subtract this log term here from both sides. So we've got the natural log of the mod of y minus 3 times the natural log of the mod of x minus 4, and that equals the constant c. Now we need to group up the log terms. But we can't group them up just yet when we've got this 3 in front, so we need to get rid of the 3 and we use the power rule for logs. That is, that 3 can go up inside that log. In other words, it is the log of the mod of x minus 4 all cubed there. Okay? So that's the power rule for logs, which you should be familiar with, and it equals that constant c. Now we can group together these logs by knowing about the rule of subtraction, that this is the same as a division. Let's just come down here, okay, and we can finish this part off. This is the same as the natural log of the mod of y all divided by x minus 4 to the power 3. And that equals the constant c. Now remember, we're trying to make y the subject, so we have to get rid of this log here, the natural log, so we need to anti-log it. And again, I'm assuming that you're familiar with this, otherwise you're going to need to go back to my earlier tutorials on logarithms, okay? If we anti-log both sides, this becomes y over x minus 4 all cubed, and it equals e to the power c. Now e is a constant, and so is c a constant, so this constant raised to a constant is also going to be a constant, and so what we tend to do is then just amalgamate that into one constant. So we've got y over x minus 4 all cubed equals a constant, and I can call it any letter I like. I'm going to go for the capital letter A. We do tend to use capital letters for constants. Okay, so if I need to make y the subject, we're going to have therefore y equals that constant a multiplied by x minus 4 all cubed. Now that's one way of arriving at y. There's other ways that you can do it. I'll show you another common method that is used. Let's go back to this line here, okay? We'll just put a star there and we'll go from star. Okay, let's just see what we could have done. Now, when we've got an equation with logs in, you'll often see people do this. I'm just going to copy out what we had there. Natural log of y equals 3 natural log of the mod of x minus 4. But instead of writing plus c, what you'll often see done is some people will write plus the natural log of a constant. Let's say k if you like, okay, or a. It's up to you, you can use anything you like. This will be a constant value as well. Now, the advantage of this system is we've got a log equation, but we've got logs in every term. You can't just divide through and get rid of the logs. It doesn't work like that. You've got to reduce your equation down to 2 terms, just like we did over here with logs, okay? If you want to get rid of logs, you've got to reduce it down to 2 terms. So, how do we do that? Well, we can write this as the natural log of y, and we can bring the 3 into here as we did before, so that's the natural log of the mod of x minus 4 all cubed, and then plus the natural log of the mod of a. Now we have just a log plus a log, no number in front of any of these logs, so we can group them together using this addition rule, which turns out to be the log of the mod of y equals the log of the mod of a multiplied by x minus 4 all cubed. I'm assuming again you're familiar with that rule for logs. Okay? Now we've got 2 terms, we can anti-log, but because both of them have natural logs on both sides, then when it comes to anti-logging, we just remove those logs. We get y equals a multiplied by x minus 4 all cubed. So you have 2 versions then of achieving this result here, that y equals a bracket x minus 4 all cubed. So there's our answer, okay? Either approached from this direction or approached from this direction.